Okay, no, it says that's the record.
Yeah, it has started.
Yeah, okay, perfect.
Okay, so once again, welcome everyone to this national seminar on mathematics education. It's very nice to see you again. And so it's a monthly seminar, and we try to stick to the second Thursday of the month, which is indeed correct for this month. And so we focus on all aspects of mathematics education, and people who work within the Netherlands usually present their latest research. And for today, that will be Sharon Calor. So let me just tell you one more thing. So generally we talk for about 45 minutes or so, and then, sorry, there's a presentation for about 45 minutes, and then we have 45 minutes discussion. And well, for today, our speaker is Sharon Calor, who works at the University of Amsterdam, also at the University of Applied Sciences in Amsterdam, and also, but I'm not entirely sure of that, whether you still work at the school in Belmar.
I have a sabbatical coming year, but I also work at the Free University of Amsterdam.
And at the Free University, so 4 employers. So that's a record for as far as I know. I don't know people who have that, but okay, you have a sabbatical. Anyway, so Sharon does a lot for that has to do with mathematical education. So I think teaching new teaching new teachers, training new teachers.
Yes.
And also doing research, working on a PhD thesis at the moment. And I think the research that you're going to present today is part of your PhD research.
Exactly.
And
yes.
you almost already have a date for your PhD defense. Is that true?
Not quite almost. I have to finish the general introduction and discussion. So.
Okay, but it's not so far away.
It's not so far away.
That's wonderful. And at least so we get the sort of preview, sneak peek, although this will be about maybe a paper that you've already published.
Yes, it's a paper that I've already published, indeed.
Okay, well, this will be the things I have to say about you, and from now on the floor is yours. Thank you for being here today, Sharon.
Yes, thank you. Thank you. It's quite an honor to present my work here today. Thank you for the invitation, Rogier and Paul, of course. And I will switch to try to share my screen and then switch to the presentation. I will not be able to see your hands. So Anna or Rogier, if you have a question, they will tell me.
So Sharon, does it mean that you appreciate questions during the presentation as well? Or you will make yeah. Okay, so if you have a question, then just raise a hand or write in the chat.
Okay, I hope everybody can see my screen. All right?
Yes.
Okay, thank you. So my PhD research is at the University of Amsterdam. I've been conducting this research with a grant, the Promotiebeurs voor Leraren, a special grant for mathematics teachers. And I must say it was a wonderful opportunity to be able to conduct my research. As Rogier already announced, I'm still a mathematics teacher at the Open Schoolgemeenschap Bijlmer in Amsterdam. And this school is a very special school, a secondary education. In the 7th and 8th grade, students of all levels sit together in one class. So students with track, vocational track, the lowest level, all the way up to the pre-university level, sit together in one class. And also during the working phase, students sit together in small heterogeneous groups of 4 students, and all with mixed ability. So different levels. This is, of course, challenging for a teacher. So how do you teach and how do you guide small groups during group work? So the structure of my presentation will be that what I just said, give a sneak preview of my research context. Then I will proceed with a definition of mathematical discussions, and then with one of mathematical level raising. And then I will share a group task that I developed with you. And I will share the work I've done on developing the small group scaffolding tool. It's a tool with which you can guide small groups during group work. Then I will share some results from this study, this paper. So I'm sure that most of you are familiar with the work of Freudenthal and the Van Hiele on the level raising theories. And I use in my study the definition of a mathematical discussion as a discussion in which students are challenged to reflect on mathematical activities. So as Freudenthal used the term human activity, mathematics is really a human activity. Okay. Because I'm sure you all are familiar with the Van Hiele theory, level theory. I skipped that and I used the level raising theory of Freudenthal. He stated that level raising is really the process when a mathematical activity that's performed at a lower level, that activity itself becomes the object of reflection at a higher level, the next level. So for instance, at a lower level, so when you're studying word formulas or early algebra, which I'm doing in the 7th grade of the Open Schoolgemeenschap Bijlmer, early algebra is introduced. When at the lower level, the patterns of, for instance, a table setting containing tables and chairs are studied. And then at a higher level, the next level, these patterns themselves become the object of reflection when you are trying to create a formula that calculates the number of chairs given the number of tables. So this work I've published in a previous article. And what the literature says and what we observed in our in the classrooms that we where we asked the children and the teachers to work with these group tasks, we found that teachers find it difficult to support small groups, even though at the school, because I conducted the research at one school, even though the teachers are used to working with small groups and the educational concept of the school is really collaborative learning. So group work, all students working on one task at a time and not dividing the task into several parts and then joining the several answers at the end together, but really working on one task. But even though teachers were used to that, they still found it difficult to support the small groups. And why? You have to attend to the needs of all groups at the same time. you are confronted with difficult questions of what kind of support to give, and you have to make those decisions instantly. So because of, and Van Leeuwen and Janssen also wrote in their review, gave a few yes, what they said is that teachers find it complex. It's a complex activity. Okay, so what we did, we developed the small group scaffolding tool in order to help mathematics teachers support these small groups. Secondly, we designed lessons, specially designed lessons that evoke mathematical discussions. And then we investigated the scaffolding behavior of the mathematics teachers. And I'm sure that some of you already are familiar with the work of Sonia Palya. Sonia Palya was a PhD student, also a teacher, mathematics teacher, who conducted her PhD research also at the University of Amsterdam. And I am building on her design principles. She developed design principles for what she called so-called shift problem lessons. So those shift problem lessons are lessons that evoke mathematical discussions. And they are called shift problem lessons because they are aiming at a shift in the mathematical knowledge of students, really a level raising. So we shift in levels. Her three design principles are that the designer is guided by the learning goal of a deeper understanding of mathematics. And in my case, we're talking about word formulas, so early algebra. The second design principle is that mathematics has to start at a level that is experientially real to students. So I just had a discussion with the students in my mathematics education class. It does not really mean that the context has to come from the outside world, so from the real world. In my case, students, if you remember the table setting that I showed you, small tables and small chairs, the children are really used to working with those within the chapter. So that becomes experientially real to these students within this context. And then the third design principle of Sonia is that reflection can be induced through mathematical discussion. But the definition of Freudenthal for level raising was that, go back to that the patterns that something that you study at a lower level becomes consciously becomes the object of reflection at a higher level. So the third design principle of Sonia Palya is that reflection can be induced through mathematical discussion. And so inherently, this reflection then induces level raising within children. So that's the idea. For this study, we particularly used the learning goal. The first design principle was that the designer is guided by the learning goal of a deeper understanding of mathematics. We used the theory of Janvier, 1978. 87 is a while ago, but still I find it a very useful theory for learning algebra. Is that he stated that learning algebra could be done best when you teach children to switch from representations of algebra, the 4 representations you see here in the top row in the left column, the situation, tables, graphs, and formula. If you teach children to switch between these representations in a pairwise manner. So for example, you go from a graph to a situation, and then back from a situation to a graph. Oh, that's not so very good example, but from situation to a formula, that's a better one. And then when you have the formula, you can ask children to create a new situation. That's exactly what I've done with some tasks of the conventional textbook. Oh, I forgot to say that because the design principles that Sonia developed were especially made for tasks within the conventional textbook of mathematics teachers, because mathematics teachers are always always pressed for time. The curriculum is overloaded, and it helps when you have design principles to adapt a given task that you already have in your textbook, then to create a whole new task. Okay, so this is an example of one of the tasks of the conventional textbook that we used in the classroom. There is a pile of tiles in Marco's front yard. Those are gray tiles and red tiles. And then students are asked, so in exercise 1, how many red tiles lie in the path? And how many gray tiles lie in the path? How many gray tiles lie next to every red tile? So they are really guided through some small exercises. And then in the second exercise, it's asked that if you know the number of red tiles, you can calculate the number of gray tiles and then fill in the blanks. And then in the formula, in the word formula, you have to fill in the blanks at the space there. And then some additional questions are asked. I've adapted this task and using the design principles of Sonia Paglia, and also using the theory of Janvier. Remember that according to Janvier, learning algebra is done best when students learn this in a pairwise manner. So switching from one representation to the other and then vice versa back. I used a concrete material. So the students were already familiar with the tiles because this was not the first exercise with tasks. So it's experientially real for them. And I used concrete material. I printed out really hundreds of red tiles and hundreds of gray tiles and then cut them all out by hand in the beginning. And later on, I had help. And then students were given a small group of heterogeneous students were given a stack of gray tiles, and the groups consisted of 4 students of mixed ability. And they were all given a stack of gray and a stack of red tiles, really cut out of prints. And then they were asked to create a tile pattern of red and gray tiles with which they could create a formula in words. So this is the situation, the representation situation. Then they were asked in exercise B to create a formula in words that corresponds to this situation. And here it comes, the pairwise manner, right? The vice versa. And now they are asked to create a different Freudenthal pattern, so a different situation, also corresponding to the same formula. So here you have the back and forth switching, the translation skills, as Janvier called them. Okay, as I said, teachers find it difficult to guide such groups, and then we developed a small group scaffolding tool. In construction, as many of you already probably know, is that a scaffold is used as a temporary structure that you place beside a building when you're constructing a building. And I meant to say, you already know that scaffolding within education really represents a teacher's temporary adaptation to a student's understanding. So if you can see that in front of you, within your mind, you have the scaffold, and then you have the student's understanding, and then the teacher gives support just within what Vygotsky called the zone of proximal development of such a student, just a little bit above the scaffold. Okay, so now we come to for my interesting part, the small group scaffolding tool that I've designed. So really, what does it entail? I hope you can read the letters. They seem a bit small on my screen, but in the first step, when a teacher joins a group, the first thing he's recommended to do, according to my tool, is to determine whether the group has really reached its maximal level of understanding. What I mean is, what I would like to do, teachers to do, if give small group support within the zone of proximal development of the whole group. There's not just one student within the group, but the whole group. And then, because when this is not the case, when one or two students in the group, for instance, understand the subject matter, then you really do not have to give content support, because the knowledge is already there within the small group. So you can ask students to really continue mathematical discussions by explaining to each other. And this is the lower part. It's a branch, you branch out. In the first step is determining whether the maximum level of understanding of the group has been reached. When one or two students understand the subject matter, this is not the case. So then you follow the arrow, the lower arrow with a no, labeled no, and then you provide what we call process support. So you really would like the process of discussing mathematics to continue. So then you can ask one student, so you really understand it, so please explain it to the others in your group.
Sharon, because I raised my hand and then I realized you don't see it. Very quickly, just a clarifying question, if possible. By this one, you mean if the group reached the maximum level of these 4 Van Hille levels, or you mean group's maximum level?
Group's maximum level, what the group understands. So when I explain the scaffolding for one student, the scaffold was at the level of what one student understood. And now I'm talking about a whole group. So when the group is stuck, really stuck, then they have reached their maximum level of understanding, and they really need content help from the teacher. But so when
yes? Just that I understand correctly, so that within the group they can't go further because
continue.
within the group there is already the maximum whatever exists in this group. And if someone has a higher level and some others low level, then probably they still can go further themselves.
They can go further themselves. Yes.
Thanks.
And as long as they can go further themselves, teachers are when they are asked a question, teachers are recommended to encourage students to perform a mathematical discussion. So to explain to each other so that they can reach their maximum level of understanding themselves. They can go forward with the mathematical discussion themselves without content help from a teacher. Because there is already one in the group that understands.
So this 6, what we have now on the slide, providing, maybe I just don't get exactly how to read the diagram. So the 6 providing process support, it is this what you say now. Guys, go discuss, explain to each other.
Exactly. Yes.
Okay.
And now, when in the case when the group is really stuck, they cannot go any further because none of the students can come up with something to go further. None of them knows how to go further. Then you have the upper branch. So the maximum level of understanding of the whole group has been reached. And then it's time to give content support. And how do you do it? You give content support really within the zone of proximal development. That's the idea, to give content support within the zone of development of the whole group. So, but then you have to diagnose what they already know. You have to build on the mathematical ideas that the group is already discussing. Because the ultimate goal is that the mathematical discussions can continue so that reflection can take place, and then, according to Freudenthal, level raising can take place. So in the second step, teachers are recommended to diagnose the group's maximum level of understanding. So really to find out what mathematical ideas the group is discussing, so that the teacher can adapt their content help to these ideas. And then the third step would be to check whether the diagnosis is correct, to come to some sort of intersubjective, what it's being called in the literature, to come to some sort of agreement with the student that is really the question. And then in the fourth step, that is the step in which you actually give mathematical content support. But the support is aimed at, in order for students, for the group to continue the discussion. Because I earlier, when I mentioned the metaphor, it's a temporary adaptation to the level of a student, and it's a you give support, and then you give the responsibility for learning back to the student, and in this case, back to the group. So this is a very difficult step for teachers. They are also mentioned that in a post-interview, because here they have to give support really until one or more students understands the subject matter, and the students can, the group can continue mathematical discussions. So you give just enough support, just enough content support for mathematical discussions to continue. You build on the mathematical ideas the group is discussing, they are stuck, and give just the amount of support that helps the group continue discussions. And after you've done that, you check whether the group really understood you and is able to continue discussion on its own. When that is the case, you can stop providing support, really, because the group is able to continue its discussion. So you return responsibility for learning back to the group. And then, for instance, if you see that 1 or 2 students understand the subject matter, you then go further with step 6 by providing process support, asking them to explain to each other. So really to continue the mathematical discussions. So we have 2 branches. One, when this group is stuck, cannot continue on its own, then you take the upper branch and you give mathematical content support within the zone of proximal development of the whole group. And that's really the new thing within the literature that we contributed to the literature. The small group scaffolding to give support within the zone of proximal development of a whole group. And when the group is able to continue discussions on its own, you take the lower branch, you ask them to continue by explaining to each other.
Nice. I think we have one more clarifying question. Shahaya, not sure I'm correctly pronouncing this name. Would you like to ask?
Thank you very much. My name is Shahaya Right. Shahaya Araya. I'm from North University. My question, it was really interesting, but what intrigued me is that oftentimes you have this group and they start discussing, okay, 1 or 2 students have understood. That is good. But the thing is that the other 2 or 3 of them, for that matter, claim that, yes, it is solved, so finished, even when they didn't understand that. What is the guidelines for them to understand, not just that it is solved in the group, but to really understand it, not only from the individual, but for the whole group? Is there any guideline so that they learn what this individual has explained to them, or a pair of them?
Mm-hmm.
Okay, if I thank you for your interesting question. If I understand you well, I think that more on the part of social mathematical norms within a small group, is that so at my school, for example, the educational concept was collaborative learning. So within all subjects, so the students are really used to discussing everything with each other. They're really used to help each other and discuss these matters with each other.
Mm-hmm.
I hope so.
Yeah, thanks. I think that's
it's really interesting. Yes, the thing with this is that to develop a norm, if there is a norm, a culture in the classroom, that may help them do those things. And therefore, the biggest thing is to developing a norm. Interesting. Thank you very much.
Yes.
Thank you.
Thank you. And maybe that would lead later to a discussion. Sharon, just because you wanted me to alert you about time, you talk a little bit more than half an hour. So it's good if you can talk more than 15 minutes and then we discuss.
Okay, thank you. So we then were interested in the scaffolding behavior of teachers who worked with the small group scaffolding tool that we developed. And we conducted an explorative study. And then we had 2 students working with the small group scaffolding tool, which we call SGS. So the SGS group consisted of 2 teachers, 2 7th grade teachers. They taught their own class containing 54 students, 2 classes, containing 14 small groups of 4 students, all of mixed ability. Remember, I said that the students had a level from vocational until pre-university. And then in the other group, we had the control group really, we had 2 7th grade teachers, with their 55 students, 2 classes, and also 14 small groups of mixed ability. So the intervention entails that I trained the teachers of the small group scaffolding group. I trained them on the job, meaning that before every lesson and after every lesson, I discussed the small group scaffolding tool with them. And I attended all the lessons, and afterwards we discussed the tool again, what they were able to perform, which steps they were able to perform, what they found difficult, etc. Students in both conditions worked on an early algebra unit of 12 lessons, so 2 chapters from the conventional textbook. 5 of these paragraphs of these sections I replaced with shift problem lessons, with mathematical discussions lessons that evoke mathematical discussions, which should invoke reflection, and that in turn should evoke level raising. The students worked collaboratively on the same assignment during these 5 mathematical discussions. We videotaped teachers' interactions with one group in every class during all 5 mathematical discussion lessons. And we coded the teacher steps according to the small group scaffolding model. Remember, there were 6 steps. One was determining whether the maximum level of understanding has been reached, and then you had 2, 3, 4, 5, and then 1, 6. So then we coded these steps. Iterator reliability was determined with 10% of the data. We did reach a high level of iterator reliability of 91%, and Cohen's kappa according to Fly's kappa benchmark was 0.82. Good enough. Our research questions was, what are the effects of applying the small group scaffolding tool on teachers' scaffolding behavior during mathematical discussions? Well, I will ask you, I have here I have a table of the sequences of steps that the teachers took according to the tool. I will ask Anna and Rogier to make some breakout rooms for me, and then you can choose to discuss these sequences in a small group, or discuss the tool, or discuss some other results that I will show later on. So as you can see, so maybe I can show the tool again, and then you can quickly look at the numbers and what they mean. So 1, 6, and then 1, 2, 3, 4, 5. The 1, 2, 3, 4, 5 is when you give you scaffold the whole group within the zone of proximal development of the group. And then you can see a difference between the teachers in the small group scaffolding group and the teachers that did not work with the tool. In the group of the teachers that did not work with the tool, the steps they took were mostly 4. 4 is giving content help, mathematical content help. And within the group of the small group scaffolding condition, you can see that teachers used more steps. 1, 2, 4, 4, 6, 5, 6, etc. So they were able to use the small group scaffolding tool. That was the first observation. These are some frequency percentages which you can discuss within a small breakout room later on, if you'd like, if you're interested here in this. We also found that the teachers that used the tool engaged more students in the teacher small group interaction than the teachers that did not use the tool. So the teachers that used the tool engaged mostly 3 or 4 students, so mostly the whole group, while the teachers that did not use the tool mostly addressed 1 or 2 students within the group. Later on, I will show an excerpt, a contrasting excerpt, one in the small group scaffolding tool and one in the group that did not use the tool. So just to remember, I'm showing the tool again. So this is an excerpt within the small group scaffolding group. So the small group scaffolding condition, the lower branch, 1-6. It's an example of that path. So the teacher was helping students make an arrow chain, and when she left, she was trying to leave, one of the students asked a question. But miss, what does an in number actually mean? So this was clearly a question of one student. And so then the teacher performed step 1 by asking, who knows what the in number here means? And then she pointed to all the students within the group. And then student 1, student 3 asked the question, and then student 1 knows the answer. He says 1. And then the teacher really performs step 6 because she knows that one of the students knows the answer. And she asked another student, please explain that to student 3. So she gives process support, 1-6, because the maximum level of understanding of the whole group had not been reached yet. And then student 2 explains it. He says, if you buy 5 drinks, then the in number is 5 in a narrow chain that works that way. And then student 4 asks, 5 is the in number. So the mathematical discussions continue, and the teacher is really satisfied with what's going on. And then she returns responsibility for learning to the group by nodding and walking away. Another example, this is an example of when the maximum level of understanding of the group has been reached. And so this is an example of the upper branch. So 1, 2, 3, 4, 5, and then ultimately 6. And then I hope,
Sharon, can I have just one more clarifying question?
Yes.
This diagram with arrows that you show us, that's exactly the tool that was given to the teachers.
While you are asking that question, I'm switching to this because this one is better to follow. This is an example of when the group's maximum level of understanding has been reached. So the teacher is now required to give mathematical content support within the zone of proximal development of the whole group, and really to build on the mathematical ideas that the group is discussing. So not coming up with a whole new idea, but building on the mathematical ideas. In this case, the teacher just approached the group and asked, are you processing? Are you progressing? How's it going? And then student 4 says no. Student 2 also says no. And then the third student says, we don't really have a story. The students were asked to create a context, a situation for a graph, and then to create, first they were asked to create a formula for a graph, and now they were asked to create a situation, a story for that formula. And then student 2 explains, we don't have a story, but we do know the formula. The teacher, so the teacher is really diagnosing what the level of understanding of the group is, and whether or not the whole group is stuck, and what the mathematical ideas are. So she asked, how does the formula look like? And the third student 3 answers times 5 plus 20. Okay, what kind of stories can you come up with? They have a story about the handyman. They had a story the day before about, yes.
Sharon, just a little question. So when you mean maximum understanding is reached, is that the same as being stuck?
Yes, the group is stuck. So they reach their maximum level of understanding together, all students within the group. They cannot continue on their own.
Yeah, it's good to know. I think because to me at first it means something else, maximum understanding. But
okay,
if
yes.
just being stuck, that's much more easier to
it's
to
easier
establish.
to okay, yes.
Yeah.
So the group is stuck. They cannot. They had a formula. They came up with a formula, but now they are asked to create a story for that formula. So they were given a graph and they had to create a formula. They were able to do that, but they are stuck. They cannot create a story, because the graph started at starting point 20 and the slope was 5, but they really didn't know what to do with the 20. So 0, 20, coordinate 0, 20, they didn't know what to do with that. So they had a story about donuts the other day, but that didn't work now because people buy donuts, but you don't pay 20 euros for 0 donuts. The intersection of the graph with the y-axis. And then what could that 20 be for? The fourth student asks. And they're still stuck. And then the teacher asks a question. But you also had stories about the swimming pool, didn't you? There were exercises in the textbook about swimming pools, and then you have to pay an amount for a membership, so that she really gives a hint. And then the other students were still thinking about golf, a story, and then one student understands, and she says, oh, membership. And then she is relieved because she understands that the hint about the swimming pool exercises. She now knows what the 20 could be, how the 20 could be incorporated in an question. Okay. So really at that point, the teacher stops, and I did not place that in the table, but the teacher sees that one of the students understands. She stops, she listens for a while to the mathematical discussion, and then decides that she can return responsibility for the group, because student 2 understood the question and the group was able to move forward. And now an example of a teacher providing support to a small group that did not work with the tool. Remember when I showed the frequency table? That teacher mostly used step 4, so mostly gave mathematical content support. without the diagnosing what mathematical ideas the students were talking about. So one of the students asked, do we have to incorporate more expenses than the cost of an entry and consumption items? They were also working on an arrow chain. And then the teacher asks about what the in number is, and then the student asks 2. The teacher goes on with asking, how many consumption items do you have? We have 3 consumptions. And then other student explains you have the number of euros is 2. And then the teacher gradually helps the students to the answer. He really helps them solve the problem. So no mathematical discussions continue after this, because he helps them with everything, really. He gives content support until the discussions stop, until they don't need any help anymore and they have the answer. So no, the teacher says you have to leave that open. So consumption items is your in number. Write it down. And then times 250. He really gives the answer here, times 250. And then you have a between number plus. And then he says here, look, there you have it literally. He gives the answer. The arrow with the multiplication, the between number, and then the addition. And then the student too says, all right, and then the teacher moves away. Okay, and then I'm going to try to switch back. Yes.
Yeah, maybe we go to close to conclusion?
Yes. Right on time, because this is I'm going to ask Anna and Rogier to create 4 breakout rooms, and I have a Padlet, and then you can discuss one of the 4 items, if which one you like. So maybe the group task itself, the small group scaffolding tool itself, the sequences of steps that I showed, or the excerpts.
Sharon, and for how long do you envision these 4 groups?
So 10 minutes? Would that be okay?
We could do it, but we could also stick to the usual format where we just discuss in group. I don't want to impose it, but
No, that's all right. We can discuss it because it's already 4:30. I see. So we can discuss it maybe in the whole group.
Yeah, I have an impression that there could be interesting, that we have enough time to listen to everyone, and there is already maybe quite some considerations. Okay. Yeah.
Okay.
So let's see. If it doesn't go, then we stick back to the groups.
Okay.
Yeah. So please, if you have some kind of observations, clarifying questions, thing and the broader discussions, could you please raise hand? Or if it's for some reason not possible to speak, then put in a chat.
We stop sharing for a moment so I can see the participants.
Yeah, let's see, because if I of course have plenty of questions, but let's see, maybe did we do this small group thingy?
We could have a question too, but maybe we should look at our other participants.
Okay, then let's take a decision to do 10 minutes break. Not break, sorry, 10 minutes breakout rooms. Okay. Indeed. So you said just to go to the Padlet, right? Can you put in a chat, Sharon, the link to the Padlet?
Yes. And
on this Padlet, we will have instructions for each group?
You have in the Padlet you have 4, let me see, excuse me, I'm not really good at multitasking. In the Padlet, you have the 4 things that I mentioned, so you can discuss the tool, the excerpts, or the tasks, and I can also place the tasks and the upserts. I have PDF files, so maybe I can place them in the chat also.
Yeah, there are a few issues here. Can everybody actually see the chat? Because guests sometimes do not have access to the chat. Or maybe Microsoft has finally improved this. Is there any guest here that's not in the Institute, the Freudenthal Institute, who cannot see the chat?
So I can see the chat, but I'm not able to attach my files. So I'm going to mail my files to
No, just a second. Let's stop it for a moment, because then in order to really have productive discussion, we need to see your data. So we need the screenshot of your files.
Yeah, so I'm going to mail it to...
No, Carol, Carol, sorry, while you will be mailing it to Rohir, we will put it on a tablet, we will end up after 5, really. Yeah, I am sorry to intervene this way, but I think that is the most strategical decision is now just to dive into the question that we have for the moment. So for example, I have a question concerning your tool for the teacher. I have noticed that the numbers 2, 4, 5, and 6 were actually quite sometimes coded but 5 very rare, but 3, for example, and 1 were completely absent there. Did you have some kind of an explanation? Is it something that is not useful for the teachers? Maybe it's good if you share the slide with the tool now, because I can imagine we don't all have it in front of us.
Yes, let me find the tool. Yes, so this is the tool. One did occur, step 1 did occur, but less than the others, indeed. Step 3 did not occur at all. And in the post-interview, I asked the teachers why they did not conduct step 3. And they said that they did do so, but they did it within their head. They did it automatically. They did not say it out loud. So that is one. They said it was easy to do, that they always do that. So that's one explanation. And why step 1 did not occur all the time is because we also coded the instances when a teacher approached the group and was just started to read read the poster to see what the students already have done. So sometimes they skipped some of the steps.
So it's not like they skipped, but it was not explicit in the dialogues. That's what I get from it. So they were still passing through them quite regularly, but your methodology kind of didn't allow to catch it.
Yes, I wasn't able to measure it. Yes.
Okay, that's very interesting. I think that there are some things that are kind of running on the background of the process.
Yes.
Yeah, thanks. Yeah. What are the others observations, and also if there are like clarifying questions or associations, you're also very welcome.
I was wondering. Oh, sorry,
Michiel.
Yeah, maybe I missed it, but to what extent were the teachers prepared in using the tool, not only in how to operate it, but also in the aim of the tool, and that they understand to delay content feedback, but try to emphasize process feedback and not too soon, and
Yes, I trained them. I trained them on the job, and I interviewed them afterwards also. And they said that they found that the most difficult thing they found was not to give content help as they were used to, because they were used to give a lot of content help. So to constrain to give from content help was the most difficult part for them. And they found it interesting that this new type of guiding small groups resulted in more mathematical discussions than they usually see within their classes.
And interesting. And what do you mean with training on the job? You observe their lessons and...
Yes, I trained them for a few hours before the intervention, and I attended all of the lessons, and they had a A3 poster with the tool on their desk. So every 10 minutes or so, they looked at the tool in case they forgot some of the steps. And after the lesson, after every lesson, we discussed the tool again and discussed what kind of difficulties they encountered and so on.
Okay, thank you. Rogier?
Yeah, Rogier. Yes. Mike.
I had exactly the same question.
Yeah,
how the teachers were prepared. So.
Sorry.
Okay, but we have also a question from Paul.
Yeah, sorry, I'm in public transport. Can you hear me?
Yes, I can hear you.
Okay,
fine.
good. Hey, thanks for your talk, Sharon. I was a bit puzzled by this notion of, I think it was step 4, in which the group, when there's content-specific feedback by the teacher, at the level of, and now that's the problem, at the level of the group's zone of proximal development. But yes. I would guess if a group gets stuck, that doesn't mean that they share a common zone of proximal development. It can be still at quite different levels. So how do you, when a group is stuck, as a teacher, determine, well, which level to jump in? That looks difficult to me.
Yes. Okay. So maybe I should be more precise that within this context, within the problem they are facing, within that zone of proximal development, and not the broad zone of proximal development of all students, but really only this small part with what they are discussing, what they are stuck with, because they cannot continue the discussion on their own.
So if I get it correctly, according to your definition of this first being stuck, means yes. that they all students reached the same level because they can't guide
for this
each
particular
other.
small problem.
For this particular small problem,
yes.
which exactly
not the broad mathematical level of the students, but this particular small problem. So as in the example, none of the students were able to incorporate the starting point 20 of the graph within the story. So they all reached their maximum level of understanding about that small particular problem.
And then zone of proximal development is indeed like a little bit unified for them.
Yes.
Coming back to Paul's question.
So that's how I mean it, Paul. Okay. Do I make sense?
Okay, we believe you made sense for Paul.
Okay, Paul hasn't.
Let's come back to Rogier since he has another question.
Yeah, so I think I connect a bit to Paul, but I think so the language you use for a local problem comes a little bit from actually what is used a bit more generally, like maximum understanding usually means for a whole subject, and zone of proximal development also usually from more general, not for one problem. I would say they get stuck, and then, but that's a remark, and then the zone of proximal development in this case is sort of more like a hint or a suggestion that fits them all. And this is exactly, again, a problem because they may be of quite different level. You say mixed levels in the group. So
Yes.
what maybe, if I think also for my own research, you can give hints on different levels of abstraction. And this is a
Yes.
problem with such a mixed group. Like, on what level will you choose the lowest level? Will you tell them, no, well, this is the next step? Or will you give them more like heuristic support that is a bit more abstract? How do you deal with these mixed levels within these small groups? And that has to do, like, I think what Paul said, what is the zone of proximal development? Because in this sort of microscopic way, that would mean, like, what would be the most suitable hint or heuristic for each member of the group, but that might actually not be the same.
That's very interesting remarks. I'm very happy with your remarks. I did not take that into account, the different levels of abstraction at which you can provide support. So I really cannot say much about that, but it's a very interesting approach, because you can, when you think about the switching, the Chanvier switching, you can, a more abstract level would be to give support. Oh, so now I'm really thinking out loud. To give support, to call the switch with the formula more abstract than other switches. So, and then, but that's probably
Can you
not
just
what you
explain?
but
Just explain, what do you mean by these switches?
Oh, the switches were the translations between the representations. So often of algebra. So according, you have the 4 representations: graph, situation, formula, and the 4th. Just missed the 4th.
Natural language.
Yes, and then what I did not mention was that all switches containing formula I considered for level raising. So a switch from situation to graph, that's, I did not consider that as level raising. So when you give support, I could have made the distinction between giving support according to the switches, every switch involving a formula, and the ones that did not. But I don't think that that is what you mean, Rogier. You mean something else, but this was just me thinking out loud about what I did do, and what you are saying I did not take into account. So it's very interesting points that you're making. Very happy that you're. So thank you.
Good that we developed somewhere. And sorry, I'm again not sure how to pronounce the name. Czechia?
Yes. Yes, it was really interesting.
Thank you.
By what I commented earlier, I was like closer to the idea of Roger, if I'm calling it right, you know. Anyway, I kind of accepted the idea that if there is a norm developed in the classroom, that they don't fear to just speak out their feelings, their understanding, or the questions, the doubts, and everything, so that they can kind of bear to those who can explain. That was the point in the first one. That is just a comment. But my question now is, as for the training you made with the teachers, I'm not sure if I catch how many times, how many hours, or how many interventions you had with the teachers, not with the students, but the teachers.
Yes, we have 5 interventions.
No, not with the students. Just
no, with the
training
teachers also. with the teachers also. Before every intervention, so we had five lessons, and then before every lesson, we had a training session with the teacher, and after every lesson. So in total 10 times, one before and one after every intervention.
So the documentation you have or the data you collected is after the teachers had a good training.
Yes, the interview, the post-interview I conducted after the whole lesson series. So after all 5 lessons.
Okay. Well, in a sense, what I mean is that there is equally, I mean, not only with the students, but also with the teachers, that there could be one difference among the teachers. The other thing is that have they code those things that you intend to impart to them? Have they mastered those things, and therefore that could be a contribution, a contributor to the deviation between the two groups? Or
yes, what we did, we paired. So you're asking, if I understand correctly, 2 questions about that some teachers might apply the tool differently, and then how we coded the teacher steps. We paired the teachers according to their age and experience, and then randomly assigned one to a condition. So we hope that more or less
just to understand, you mean these 4 teachers? That's how you divided them to 2 groups?
Yes,
randomly.
That's how we developed the 2 groups.
Okay.
So you hope that they are more or less the same, the teachers in the small group scaffolding condition and the teachers in the control condition. So we pair them according to age and experience, and then randomly assigned one to a condition. And then the other part about coding, that's a really complex issue, which I was thinking about it yesterday if I would incorporate it in the talk, because it's very complex. We used a coding scheme, an existing coding scheme of Janneke van der Pol. She developed a coding scheme to code the teacher help, and then one student, the help of a teacher to one student within the group. And actually, I incorporated the coding scheme at the end of my, so this was the task they were working on, what I was talking about, the graph with the slope and the starting point 0, 20. This is the coding scheme. It's a very complex coding scheme, but I anticipated a bit about the question. So what she did was she had levels of degrees of control a teacher has. A teacher has when they provide help to a student, and then you code it accordingly. It's really a complex system.
Just to clarify, but she develops it to study hangover to independence, right? So yes. she studies in scaffolding how well students come to work without a teacher. Janneke van der Pol.
Well, she studied how a teacher can scaffold an individual within a small group. So she had a model, the contingent teaching model, which is very, very similar also, but I adapted the model and added some other steps, like giving process help and determining the level of the maximum level of understanding of the whole group. So I added to that model, but we also coded whether or not as she did with this coding scheme, whether or not the content help a teacher provided was contingent, which she calls contingent, or adapted to the understanding of an individual, and in my case, adapted to the level understanding of the whole group. So this is really too complex to get into during this presentation, but it looks like this. But I will ask Rogier to place a link to my article in which it's better described than I can do now, because it involves the coding of student understanding, which you can see here as SU. SU means student understanding. And then there is also a claim that earlier was mentioned by one of you. When a student claims something, or when a student elaborates on something, and what kind of degree of control a teacher has when he gives support. But
Sharon,
really too much for now. So.
Just to conclude this understanding, and based on these few codes, which were like on control, on contingency,
yes.
You would position this moment within your tool, like what is happening within these 6 stages that we saw before.
So and then it would be the 4th stage, when you give content support, and then you adapt your support to the level of understanding. So you give contingent content support to the whole group. So you adapt your support to the group. And so that is how I coded it, and that is how I looked at it. Not really. So you might ask a broad question. You might, and not really, as Rogier was suggesting, to provide a heuristic. So it's coded in another way to be adaptive.
So
it's really a limitation. It's really a limitation of my coding scheme. So that's why I said, Rogier and Paul, that I'm very glad about your comments.
Yeah, but I actually think it's not limitation of your coding scheme. It's just that you are trying to distinguish not an attribute of a phrase itself, but of a whole situation of interactivity, right? And assign it to some particular position. That's why you take into account a few aspects. Yes.
Yes, but ultimately so maybe that would be future work to do both.
Yeah. I would like to suggest to come back to the Chihaya comment that there was at the beginning, because I think that's a kind of a broader topic, but maybe you have some insights. He was saying like, yeah, good. If there is already a culture in a classroom to share each other's opinion, to explain things to each other, then it can work.
Yes.
But what if there is no such culture? What do you think? Would your scaffolding, would your tool for scaffolding help, or should there be a completely different tool or whatever? So how can you arrive to such?
Yes, I think you have to then also focus on teaching students how to work with each other. So teach social mathematical norms within collaborative learning, so that you help them work together, you help them explain to each other, explain to them how to do that. And also the later years, the last few years, there is a focus on listening. So you have to teach students to listen to each other.
So do I understand it like for the school for these classrooms where you were working, these aspects were not actually so much needed And that's why
Those
they're
are-
not
yeah.
in the tools. That's why
Yes.
they're not. So it's a kind of
Yes.
a local applicability of this tool to a classroom with already collaborative
Yes.
environment. Yeah, thanks. Yeah. Are there more comments and questions? Otherwise, I just go on. Yeah, maybe remarks or associations with, I guess the notion of scaffolding is not so very much in use in our mathematics education community. At least I don't hear it very much within this seminar. Yeah, Monica, you say that you rather.
In the proefschrift of Jantien Smith, the dissertation of Jantien Smith, she very much used the concept of scaffolding, and also in her other publications. And she has also studied whole class scaffolding strategies in primary school education. I don't think she did it in secondary school, but it's well, it has been applied specifically to mass education by her. But not the small group scaffolding, with whole class scaffolding and individual scaffolding, of course, also.
And Joka also adds that it's indeed the terminology that is used in teacher education.
And it's used in teacher education.
In teacher education.
Yeah.
Yes, as Monica said, Jantien focused on the whole class scaffolding, and she expanded the notion, the key characteristics that Janneke van der Pol used for scaffolding individuals. She expanded the notion, the key characteristics, to whole class scaffolding, and I expanded the notion to small group scaffolding.
Yeah, I think this is very nice work, and Rohir says, maybe asks Rohir, I don't know, sorry for interpretation, if heuristic trees are scaffoldings, right? But the heuristic tree is an artifact, it's an object. An artifact by definition can't provide scaffolding, because scaffolding is an activity of a contingent support. So it can support, but it can't scaffold in this contingent manner and then give independence for the students. Or how do you mean it, Rohir?
Yeah, maybe it's a matter of definition of scaffolding. I don't think that's so interesting to talk about, maybe, but I would include it. I don't. To me, it takes over the heuristic tree. So the tool takes over partly the role of the teacher. Not because I think that's better, but because there might not be a teacher around. So I don't necessarily. It doesn't necessarily have to be a living being that provides the scaffold.
No, for sure. And there is a very big literature on artificial tutorial system scaffolding. Yeah,
exactly.
That's for sure. Yeah. Michiel has a comment, and Joka, was you also about to share something with me? No, okay, you just
Joka.
Yeah, just to wave. Yes, Michiel, please.
Yeah, I was wondering what is now the main kind of understanding or knowledge that you developed through this research. Is it that this kind of tool helps teachers to become aware of all these steps and how to move a bit around them and how to use them in providing this feedback to small groups? Because I think I have the feeling it's also dependent of the task, of the kind of pre-knowledge where they are, and of the didactical contract, the culture that is in the class, and maybe the specific small group. But so what is the general message that you take out of it?
The general message is that this tool provides teachers with concrete steps, or suggests steps that a teacher can take to help guide small groups continue mathematical discussions, because teachers find it difficult from practice and from which I observed and from the literature, it's known that teachers find it difficult to guide small groups. So this is a small attempt to help teachers guide small groups during mathematical discussions.
Yeah. Okay, thank you.
Because one of the things that mathematics teachers from the literature, I believe it's true, but I'm not exactly sure, found that teachers find it difficult to build on the ideas of mathematical ideas of small groups, because they have to determine these ideas within a small frame of time during interaction.
Yeah. I can imagine that learning from or building on what is happening in the small groups can also happen during a whole class discussion afterwards, but not necessarily everything needs to happen within the small group. But I understand exactly. the main message. Yeah. Thank you.
And also when Chu found from that when a teacher first diagnosed the level of understanding or what the level of understanding of a student within a group, they were more inclined, or they were better able to build on the mathematical ideas of a group. So first diagnosing the level of understanding is very important.
And Paul also adds that also tool plus your training can be used.
Yeah, because I think the tool would not probably work on its own. The training that Sharon gave to the teachers probably plays an important role as well.
Not only tool, but also the training.
Yeah, could I also ask another question, Anna?
No? Let's have the very last one, and then the rest is after end of the seminar.
Okay. Sharon, at the start you mentioned levels like Van Hiele. Okay, there's an announcement in the tray now, maybe you hear it. But you mentioned the Van Hiele levels, and you said I'm not going to speak about them in detail, which is fine, but did they play a role anyway in the rest of your study? Because I think I could follow it without any need of Van Hiele levels, or am I wrong?
No, you're very right, because I work with Freudenthal's level theory, so that Freudenthal mentioned, according to Freudenthal, a level raising takes place when something that's studied at a lower level consciously become the study at a higher level. So in this case, so there are infinite number of levels, and not the 4 that Van Hiele mentioned. So in this case, students were, in the example of the table settings, studying the patterns of the number of tables and the number of chairs. And the next level, the higher level would be that when they are trying to create a formula, these patterns themselves become the object of study. And that is what I try to evoke within the mathematical discussions that took place. So it's a very specific example.
Very specific context also for this tool, although tool is probably applicable in a broader situation, I guess.
Yes, and even with other subjects.
Yes. Okay, I think that's the moment to thank Sharon for your presentations. Thank you very much for making us think this direction.
Yes, thank you very much for the opportunity, and thank you all for your attention and interesting questions.
Thank you.
Yeah, and good luck you with finalizing the PhD.
Yes.
Rohir, and we will have a next speaker in a month, right? We already know whom.
It will be Tomais Karafi, who is now a PhD student in Groningen and who is about to finish her PhD. And she will talk about mathematics education at the university level, about proof, right? Remember well?
I think so.
Yes. So it's so nice. It's the idea of the seminar to have education of all levels. Sometimes we have elementary level, sometimes secondary, sometimes tertiary. So I'm very happy to see you next month. It will again be the second Thursday of the month. So I don't know what that is, but I'll know it very soon. It will be on the 13th of October.
Okay, thanks again, Sharon. And I'm stopping the recording.